Okay, so my name is Wajahid Chima, and I will be doing homework number 6, question number 1. Okay, so for the question, we're given that the joint density function fx of y equals bxy is for 0 is less than x, which is less than y, which is less than 1. For part A, we have to find b. So for this joint density function to be true, it has to be within those bounds. Bxy dx dy has to equal 1. So that leads to 0 from the integral from 0 to 1 by x squared over 2 0 to y, which equals 1. Play around with the integral a little bit more, you get b over 8 equals 1, and then b equals 8. So for part A, told us to find b, and b equals 8. So for part B, we have to find and sketch the marginal density functions fx of x and fy of y. So fx, it'll be in the bounds of y, using bounds of y, 0 to 1, 8xy dy ultimately equals 4x minus 4x cubed, and this is what the graph looks like. It almost looks like it looks like a semicircle, a half circle, something similar to that. So for yy, we have to find 8. We're plugging in 8xy dx. 8 we use in the first part of this problem, and the second part we're using the b value we found in part A. The bounds of x, 0 to y, 8xy dx equals 8y x squared over 2 from 0 to 4, which equals 4y cubed. And this is what ultimately what the graph will look like, sort of like a half parabola. Alright. Part C is asking us to prove or disprove that if x and y are independent. So x and y are independent if the joint density function equals fx of x, fy of y, marginal density functions. We already found out the values of these specific functions. We can just plug in 8xy equals this. So 8xy does not equal 16xy cubed minus 16x cubed y. Therefore, this does not hold, and they are not independent. So for part D, we have to find the expected value of x, expected value of y, and the expected value of xy. So for the expected value of x, it's going to be over the bounds of x, 0 to 1, x times f of x, which is x, 4x minus 4x cubed dx, which equals this, ultimately leads to 8 over 15. So the expected value of x equals 8 over 15. For the expected value of y, over the bounds of y, 0 to 1, y, 4y cubed dy, ultimately leads to 4/5. So the expected value of y is 4/5. The expected value of exy, we're using both sub-pounds now. dx dy, 0 to 1, 8y squared, x cubed over 3, 0 to 4. That leads to, ultimately, it's going to lead to it equaling 4 over 9. So 4/9 is the expected value of x and y. So part D, if you have to prove or disprove that x, y are uncorrelated, correlation of x and y equals convolution x over y over sigma squared x, sigma y squared, also covariant xy equals expected value of xy minus e of expected value of x times expected value of y. So we found these values out in the previous part, so we can just plug them in. 4 over 9 minus 8/15, 4/5. That does not equal 0. So since this has a non-zero value, therefore these two random values are correlated according to this. So they are correlated. So for part F, you have to find and sketch the conditional density functions fy given x and f of x given y. Okay, so for fy given x, we just use this, f of x, y, f of x, just plug them in, and that equals 2y, 1 minus x, and this is what the graph would look like. So for x equals 0. For part B, the denominator is f of y, so we're using 4y cubed in the denominator. It equals 2x over y squared, and this is what it will look like for y equals 1. Alright, so Part G, we have to find out these values here. X will be given y, small y, x, the expected value of x given big y, expected value of given small x, big X. So expected value of x given big Y equals y would equal this. We found this in part F. So just play around with the integral, you ultimately get 2 over 3y squared. So expected value of y given x equals x. Again, we found this in the previous part. And you get 2 over 3, 1 minus x squared. Expected value of x given y is just expected value of xy over expected value of y. So you just plug in and you get 5 over 6. Similarly, for expected value of y given x, the denominator is now expected value of x. Plug in, you get 5 over 5/9 right here. So yes, this concludes question number 1. Thank you for watching.